Now let us understand how the various layers of the OSI model interact with one another by using a real-world application. So in this example, we are assuming that both the sender and the receiver are sending messages using the Facebook Messenger. That is an application. So we are assuming that the Facebook Messenger is operating on both the sender and the receiver's devices. So suppose the sender is sending a Facebook message to the receiver. So it will type something like, "Hello Muhammad." So let's say this is the message. So it has been typed in the Facebook Messenger. So you have sent me a message through an application, that is Facebook Messenger, using the application layer, and that message will come to my application layer via the same route. So this message goes to the presentation layer so that it can be transformed into another format. Now the job of the presentation layer is to convert that application message into a format that's understood by the computer. So the message that was "Hello Muhammad" that was sent by the Facebook Messenger is now converted into binary digits or ASCII codes. So these binary digits and ASCII codes are a format that the computer understands. So these messages are converted to ASCII codes or binary digits by the presentation layer. This converted data is now ready to be transported to the below layer, that is the session layer. Now before sending the message to the lower layers, the session layer makes sure that there is a channel or a communication link that exists between the sender and the receiver. So this layer or the session layer connects the two devices by making a channel, a connection, a link or a session, whatever you call that. It makes a session or a link between the two communicating devices. So it forms a tunnel. You can see the tunnel up on the Facebook on the left and the Facebook on the right. So it is making a tunnel between the two devices or between the two applications that are running on either side of the communication. So whenever there is no need of communication to take place, this session is terminated and closed. So after the channel is created between the sender and the receiver, the ASCII code or the data that was converted by the presentation layer comes down to the transport layer, so that here in the transport layer it can be sought out how to transport that data. So when the data comes to the transport layer adds the port numbers that the machine or the application is using. Suppose the Facebook is using the port number 50, suppose. So the port 50 will be added to the ASCII code or the message. So this is a message, though the dark green one is a message or a packet. So it will be added inside the packet. So the data is sent from the sender's port 50. So in other words, it will be seen as like the sender's port 50 is sending a message to receiver's port 50, and port 50 is being occupied by the Facebook in our example. So the main thing is this transport layer adds the port numbers across which the applications are running. From there, the data packet or the message goes to the network layer. In this layer, the data packet is added with additional information, just like the sender's IP address, the receiver's IP address, the routing information, and the switching and subnetting information of the packet. So the sender's address and the receiver's IP address are added on this layer because this is layer 3 and IP address works on layer 3. So the IP address of both the sender and the receiver are added in this layer. Apart from that, everything that is relating to routing and subnetting is added in this layer, and the switching protocol and the types of switching that has to be followed by the packet is also added in this layer. So this network layer adds the IP addresses, that is the sender's and the receiver's IP addresses, along with the routing, switching and subnetting information. So when these informations are added to the packet then goes to the below layer, that is the data link layer. So on the layer 2 or the data link layer, we have the MAC address. So MAC addresses or the layer 2 address works on the data link layer or the layer 2. So data link layer adds the MAC address of the sender as well as the MAC address of the receiver to the data frame. Now one point to remember is that the message or the green box that you are seeing, it is called as a packet in the layer 3 and it is called as a frame in the layer 2. So when this packet comes to the data link layer or the layer 2, it is termed as a frame. So this packet gets transformed to a frame. So this data link layer adds the MAC address of the sender and the receiver to the frame, and then this frame is sent to the physical layer or the layer 1 so that it can be actually transferred in the form of bits or signals from one point to the other point. So when the data comes to the last layer or the physical layer, everything that is in the data frame is converted into binary bits. This binary bit conversion is very useful because it is the only way through which the data can be transferred in the form of signals from one point to the other point, either through a wired channel or through a wireless channel by using signals. So every data inside the data frame is converted into binary digits that is sent over the channel in the form of signals. So this was the sender side. We moved from the application, you typed in hello Muhammad, and that was converted to an ASCII code. After the transformation into ASCII code, a session between you and me was established. When the session was established, the ASCII code was sent to the transport layer so that the transport layer can add the port numbers and TCP or UDP protocols. After that, it comes to the network layer where it was called as a packet. The network layer adds the IP address of the sender and the receiver. In addition, it adds routing, switching, and subnetting information. And when it comes down to data link layer, the layer 2, it adds the MAC address of the sender and the receiver. And when it comes to the physical layer or the last layer, every piece of information is converted into binary digits so that it can be sent as signals over the channel. So this was the left side or the sender side, and now we are going to see how everything happens in the reverse order on the receiver side. So the signals that are in the form of bits, it comes to the receiver side and the physical layer accepts it at the first place. So we are going from the bottom to up on the receiver side. So the physical layer accepts the signals or the bits. These bits are then converted into frames using the reverse process as it was in the senders. So these bits are converted into the frames or the data frames used by the data link layer. The data link layer extracts the MAC addresses and sends the data frame to the network layer. In the network layer, it is called as a packet. In the network layer, the IP addresses are extracted and it is sent to the transport layer. The transport layer sees that, okay, it is for port 50, so it sends it to port 50. So once it reaches to the presentation layer, the presentation layer converts that ASCII code or the bits into a format that the Facebook can understand or you can understand. So this is how everything happens from a perspective of a sender and a receiver in all the 7 layers of the OSI model. So each and every individual layer has separate roles. Once the messages go deep into the layers, each layer adds something to the message. So this is how in actuality or in the real world the applications work, from being on the application layer to the physical layer and from the physical layer to the application layer and vice versa. So this is how the communication happens between two communicating nodes in the real world.